Thanks very much for the invitation here to China. Here a little surprise of my topic today. When I was invited, I used to speak about things around iOS development, Cocoa development, but more recently, that's not what I was working on. And so I was kind of struggling, finding a topic I really feel confident to. What's going on? Okay. So I want to speak about something I really feel confident about, and that's what I come up with. See this as a lighthearted talk about the misconceptions and struggles of a Swift developer learning about the latest JavaScript features and oddities. Where I'm coming from. I used to work on the client-side SDKs for Cocoa, so Objective-C and Swift on the Realm mobile database. This mobile database is basically on iOS a replacement for Core Data and SQLite, which you can see for Android as well, where it is available via Java. Beyond that, it can be also used with cross-platform technologies like Xamarin on C# and React Native. And there we have JavaScript again, but more about that later. So that used to be our only product on different platforms. With Realm Mobile Platform, we launched a new product end of last year, which allows seamless and effortless data synchronization and facilitates building collaborative apps with offline support. The synchronization engine itself is built in C++, much like the core of the Realm mobile database. But the platform is much more than just a synchronization engine, and a lot of these functionalities are built in JavaScript. So let's look at Swift. How does Swift look like? Here, a very easy example. You could find something like that as examples in our documentation active. Even the same objects we're using very often, animals, dogs. So here we have a class, and we're just going to print it. The same in JavaScript. Doesn't look that different. If you go back and forth, you see not that many difference. So, wow, so easy, pretty smooth. Call me JS developer now. So, from a superficial point, what are the actual differences we have seen? Both are variable declarations with let, which I must admit, when I last looked at JavaScript, surprised me. Haven't seen that. Swift has parameter names. Well, okay, just skip that. Then we have different calls to make console prints. Very important to remember, because that's how we're going to debug our code most of the time. And JavaScript is a new operator. Okay, fair enough. And then there are semicolons. Okay, so first let's dig into the variable declarations. So when we put all everything together, we have seen we have from Swift and JavaScript var and let, and then there's this new const thing. JavaScript does as well. So what is var? In Swift, it declares a mutable variable. That also includes that it is mutable for value types like structs. In JavaScript, it declares a variable which is hoisted within the function or global scope. That means it is available even before you have declared it. And in addition to that, it's not only available, but you can redeclare it, and it doesn't cause an error when executing the program. That can lead to pretty surprising side effects. So, what is let? In Swift, it declares an immutable variable, and that is even enforced beyond reassignments for value types. So if your value type, the properties of your struct aren't actually mutable. In JavaScript, it declares a variable which is block scoped. So this hoisted definition you have heard about, that's evaded, and you can use let pretty much whenever you would want to use var. So if you would want to write modern JavaScript and your environment can support it, always use lab. That's one. So, and then we have const, and that's only in JavaScript, and it declares a variable which is block scoped and not reassignable. So, as a variable, it's mutable, but as JavaScript doesn't have a different concept of immutability and mutability as Swift has, it doesn't even have an impact beyond that. Okay, so this was one of the superficial differences. Then we have this semicolon, and the semicolon is surprisingly debatable. So, what is the semicolon programming in general about? It's about writing multiple statements in a single line. That's nice for tweets when we want to write really short code, but most of the times we use separate lines anyway to make our code easier to understand, easier to read. So in Swift, Apple decided to get rid of it basically, or just make it optional, and most developers do avoid it. In JavaScript, it's slightly different. It's sometimes optional. Even so, this as a statement is de facto true. Technically, this isn't even correct. Semicolons are required, in fact, by the interpreters, but they are forgiving. They support something called automatic semicolon insertion, and in the background, you can see a relatively complex flowchart. We are not going to look deeper into that. But just let's look at what it still can mean for our programs and how we can stumble over that. Assume we have a function where we want to return an object literal. So returning this object here or executing it in JavaScript wouldn't actually return this object as we might expect because of the way we put in new lines and what the automatic semicolon insertion makes out of that. It would actually add the semicolon right behind the return, and everything beyond that would be dead code. So this isn't really fine. Still, debatable questions. Developers do different things according to surveys, and even when you look into different popular libraries. So what can we do about it? Something you can do in general. We can add a linter, which helps us so that we don't step over that. That is obviously not the only reason why you should use a linter like this. They help to point out easy mistakes which you could waste hours on searching yourself. Like, why would this function, which looks like it's returning an object, all of a sudden just return void, nothing? But beyond that, linters are also very effective to avoid having debates about code style and so streamline the whole review process when working in teams. So you don't have to discuss whether we are going to put a semicolon at the end of each line or not. That helps when working with bigger teams at least. When you're on your own, then you won't have really a debate about that. Besides this ESLint I mentioned here on the slide, there are also other linters out there. Use whatever you like. But there's more than just the superficial. So let's take a step back a bit. What are we even comparing here? So with Swift, we are speaking about a language which was published in the year 2014 on WWDC, just 3 years ago. It's very young. And less than 2 months ago, Swift reached 3.1, and so far we have only a single implementation by Apple. There are other attempts to execute Swift in the web, but they aren't quite covering the whole as a language, at least from all I know. When we speak about JavaScript, we need to make sure what we are even speaking about, because JavaScript is around for so long time. First it came up as 1.0, supposedly written in like 3 days in 1996, and since then it has evolved quite a lot. In 2000, we saw JavaScript 1.5 as easy mainstream in the 3rd edition, and even that has changed a lot further since that. And recently, and more what I'm going to speak today about, is the ECMA script 6th edition, very often referred as ES6 or ES 2015, the year when the standard was published, but that's not even the latest stuff with all the nice features we have. New features are coming and not quite fairly decided on. In the standard for 2017, there will be concepts around async and await, but as these are not final drafts yet, not including that here. And JavaScript is supported, as we know, by browsers, and there are a lot of different browsers out there, so we have a lot of different implementations. For us, most relevant as mobile developers is JavaScript Core by Apple and V8 by Google. Beyond that, the latter here on the slide are relevant in the web. How do we deal with all of that? With, like, as web developers, especially trying to target all these browsers out there, especially the older ones, still stuck on an older standard. We can use transpilers, like for example Babel, which help us to transpile down from the new standards into older standards and add polyfills around the standard library so that we can use all the improvements which have happened over time and don't have to worry about all these differences in that sense anymore. So Swift and JavaScript support different programming paradigms. And support here can mean different things. With both, we can see imperative programming, object-oriented programming, declarative programming, functional programming, and many things in between. What most of us, I think, actually do. Like going full pure functional is relatively rarely achievable when you're developing actual apps. So, somewhat related to this discussion are different typing approaches. So let's talk about types. Swift has a strong type system. JavaScript, in comparison, has a dynamic type system. Even so, functions here are first-class citizens, so you can deal with them like objects. It's not a functional language. It is a prototype-oriented language. And this prototype-oriented is rather unique and so sometimes rather confusing when you try and start JavaScript and JavaScript object a lot. And I think a good understanding of that is really helpful when trying to get around with it. So let's look into inheritance and go back to our example that we had in the beginning. Classes in Swift should be relatively straightforward for us. Here we have a class, a base class, defining an element of just a property age, which is of type int, a constructor allowing to fill this with a value. Beside that, it implements the protocol custom string convertible, which allows to print the name and the property. And we extend this as class dog, which adds another property for power, which is also, we can fill it with the overridden or extended constructor. JavaScript in comparison has many phases. When we look at the prototypal inheritance in an extremely simplified way, we don't even take the different API availability across various JS engines into account, we have something like this. I hope you can read the code better than I, being so close to it. What we can see here is that we use a function to define our constructor and our type kind of, which doesn't actually exist as a type as in a compiled language because it's all done dynamically. And on this type, we define a getter using object-defined property on the prototype. And we define our toString function, which is using the constructor to print a name, and extending this class by defining another function var. And how does JavaScript here now whether something is treated as a class or as a function? It doesn't actually really know. It's just more up to you what you do with it. When you call a function with new, then it will fill the this context within the function with an object prototype or with an object stub, where you can make decisions on and interact with it. And it will respect the prototype inheritance. And by setting a prototype, as we do in the last 3 lines, by a new instance of the animal prototype and filling the constructor field, we can extend or let the dog function or prototype inherit from our animal so that the toString function will become available. That looks rather hard to write by yourself. And this was acknowledged when designing JavaScript, so that with ES6 it became all a lot better with some syntax sugar around it, which allows to define classes which extend over classes, and the syntax is becoming much more familiar for us. But besides ES6, we also see other approaches to what you can build around JavaScript. TypeScript is a language on top of JavaScript, and as the name implies, it brings types, including generics, union and intersection types, tuples, and type aliases, and a lot more. And TypeScript is much like with Babel, ES6 is a transpiled language for all the JavaScript dialects. A language which compiles down to simple JavaScript. And with TypeScript, you can actually use type annotations in your code. And it becomes much more closer to what we know, and we can use the advantages you have in development with static type checking. So when all of that is available and code can be compiled, why am I even showing this ugly code in the first place? As I said, with E6 even, it's all just syntax sugar. It is at the runtime level nothing else than you have seen initially. So it's good to have a proper understanding what is even going on there. While the semantics might even slightly differ depending on the actual implementation when you run a higher level JavaScript directly on different engines. So under the hood is still the same, I'm saying. The same reminds me of a topic, equality in JavaScript. So Swift has an operator equals. This is nice because the semantics are encoded in a standard library and are extensible as operators in Swift are. You can implement the equatable protocol and define your equatable operator implementation yourself, and can decide over the semantics you desire and just use it as any other class or type of the standard library. You can start to compare animals just like numbers, but not numbers and animals. JavaScript is a bit different here. JavaScript has more. It has equals and equals. And the first one has a very interesting equality table. It attempts to be really useful here by doing an implicit typecasting, but the effect of that can be sometimes rather confusing. So what we see, for example, is that string 1 and 0 equals to number 1 and 0, and boolean true and false, respectively, which makes sense for a language which doesn't have a concept of types and is dynamic, and didn't surprise me that much. But more surprising is that an empty string equals to false as well, and really outstanding than an empty array, of containing the number 0, and an array of the empty array equal to false as well, while an array containing the number 1 equals to true. So we found a different operator there, equals equal, which simplifies the semantics quite a lot and is preferred these days in the JavaScript community. If you want to have other semantics, you basically need to draw your own, but you are also responsible for using them yourself instead of using the operator, because you can't change anything about it. If we go back to this bigger square we have seen, we can recognize here that JavaScript has null and undefined, and they even equal to each other. So let's talk about null. Swift has an explicit concept of nullability encoded in a type system. JavaScript hasn't. In addition to null, everything can be undefined. What are those two, and how do they differ? Null is from its type object and is available to the interpreter, which means you can't change anything about it, and undefined in comparison is from the type undefined itself, and so rather the lonely kitten pretty outstanding. It is a property of the global object, so which makes it overwritable. So what do we do? Most developers these days recommend to rather use just the latter, undefined, as it has the clear type undefined versus the rather ambiguous type object. But we can also use TypeScript again to our rescue. This has two different explicit types for both of them, and when we would like to make use of optionals, this something which we would write in Swift like this, where we have an optional parameter, could be implemented by using these types and the concept of union types by unifying string and undefined into a more complex type. This is what when we compile with strict null checks and brings us then the advantage of an enhanced type system actually taking into account whether something is null or undefined, and so could lead to runtime errors. So much to the language and their differences. Let's talk a bit about the ecosystem as well, which is also pretty important when coming from one platform or one language to platform is that Swift runs on Mac and iOS devices, on Linux. There are plans and attempts around Android and Windows, versus JavaScript runs basically everywhere. It runs on microcontrollers, it runs on drones, on Mac apps, via Electron, which powers code editors like Atom or Visual Studio Code. This goes so far that we can say JavaScript is an assembly language. This is actually a citation by a famous computer scientist, and we can even say not only JavaScript runs everywhere, but also everything can be compiled to JavaScript. ASM.js is a strict subset, and this allows code written in statically typed language with memory management, such as C, to be translated by a source-to-source compiler such as Script, And by doing some limitations to JavaScript as a language and the strict superset which is defined there, the performance can be improved by using ahead of time optimizations. Something like this can be used to run Doom in the browser. But that's not as relevant for us as mobile developers. Let's talk about React Native. We keep it easy and quick here. The dream of React Native very often seems to be implemented at once and deployed on all platforms. The reality looks different, as the platform have very often different requirements and you don't even want to do the same. So you rather end up sharing the business logic, but not the UI. Skipping from platforms to dependency management, I want to make a quick reminder when comparing to Swift. This is interoperable with Objective-C, and we have to look here, build back into the history. Objective-C developers historically used either no dependencies and didn't want to use dependencies at all, used Git submodules, or CocoaPods. With Swift, in the advent of Swift, it had an impact on the ecosystem. A new dependency manager came up with Carthage, CocoaPods, and I was involved around these efforts. Had to support Swift as a new language, but Apple eventually also acknowledged the problem of dependency management and started an attempt to address it. All of these have in common, which is important in comparison, that they have no central code registry. You rely on private hosted repositories, most of them on GitHub, some on Bitbucket or other platforms. Not sure about local differences here. And CocoaPods has here actually a register for discovering dependencies, but these are more seen as the pod specs, which are recipes on how to build your dependencies and where to find them, rather than actual code. JavaScript in comparison has NPM for Node.js, but this is used as Node.js is used very often for local development and your CLI tooling around it. Also in other scenarios, and just the biggest registry of JavaScript packages, and so probably also the biggest registry of code in general. And to ship code for other platforms or your dependencies, there exist different approaches around that. They used to be Bower, their approach like Browserify and Webpack are relying on NPM for the package management part and packaging that up in different ways which optimize it to actually ship the code over network to web browser clients. But these are all challenges which go way beyond my talk, and you can probably speak in a dedicated talk about just that. Important here is NPM is a package manager and a platform where you submit actual code. If you're used to other environments, I have seen Ruby a lot for CocoaPods, which is written in that language. That seems to be very similar to me to like how Ruby gems work. Important when working with it yourself on this, NPM doesn't do full dependency resolution by default. And that can lead to some pitfalls, but also has some advantages in how moving forward with development of libraries. Let's take a look at this example here. We have our app, and it has dependencies to BananaKit and Monkey. BananaKit itself depends also on Monkey, but on a newer version of it, 1.1.0, and we just depend on these older versions, which doesn't necessarily have some features. And as these are recursively resolved and these dependencies can installed multiple times, but doesn't work on Swift and Objective-C, as the code is compiled, and then we would have duplicates, and it's just a whole different approach to it. Versus here, we can load different versions of library into our environment multiple times. This can lead us to some rather surprising bugs when we are not used to that and wouldn't expect it. So if you have in our app code are using these both libraries and using this monkey of the older library and want to let it visit a new banana kid tree, which is expecting the new monkey, this could lead to an error because the banana kid library is using just what it gets from the runtime, which is the old school monkey, which doesn't know about climbing. So if it wants to let it climb, that wouldn't work. So there are solutions to that, and also the problem of locking your dependencies in different versions. One attempt is just committing your node models, like people did with the pods directory, with CocoaPods. But just committing them makes sure everyone in the stream and CI has the same version, and that's the start. But approaches like npm shrink-wrap, which is built into the package manager, write a log file for the whole dependency tree, like the pod file, log file. But using that has limitations, and the workflow requires attention. Our tools were built around that to tackle these, like npm, Uber's npm shrink-wrap as a tool. But more recent approach came up with Facebook, which is a whole alternative to the package manager, which uses log files individually and makes them part of your workflow without any way around if you just stick to that. And that's already where I want to make a balance over what I'm speaking about. Is that really the state of affairs? Is JavaScript the full book and all its utilities really that bad? Are the good parts only so limited? Swift comes with a static type system, allowing the compiler to become even smarter and allowing humans to avoid errors. Language transpiling to JavaScript have at least addressed the later aspect, avoiding errors. You could argue theoretically performance benefits by optimizing the code yourself become more and more neglectable. With just-in-time compilation approach, smarter compilers, and faster and more powerful devices as we see them. But just because you use JavaScript, you don't have to build everything in there. Much like we do. We built our synchronization engine in C++, so it's blazing fast. But the features we want to build around, and the dashboard, which actually has to use JavaScript in the table to make it nice to use from web browser. So there is no definitive answer. Choose the right tool for your challenge. That also depends on who you are. Are you a big company with hundreds of iOS engineers, or are you on your own and used to build websites? My current sense is that there's a lot to learn from that other ecosystem, which moves at a different pace. In an underlying pace, maybe slower than Swift, but with all these tools we have on top and created around it, and the huge community, maybe in some ways even faster. And that finally brings me to questions. And I want to thank for your attention.